Welcome to ECD28 lecture on ECD, Electronic Circuit Design. We are going to start Class C amplifiers in this lecture. A Class C amplifier is the one for which the transistor conducts for lesser than one half cycle. We studied that for a Class B amplifier, one of our previous lectures, we studied that it works for one half cycle, for one complete half cycle, maybe from 0 to 180 or from 180 to 360 degrees, but it conducts for one half cycle. The Class C amplifier works for us for a time that is even smaller than 180 degrees. So why do we have this amplifier for which it conducts for a very small time? Well, this is there because it increases efficiency. The efficiency of this amplifier is larger than the Class B amplifier as compared to Class A amplifier. So it works for the main difference is that for a Class C amplifier it works for a very small time compared to Class B amplifier, which works for one complete half cycle. So this is the primary difference between a Class C and a Class B amplifier. So how can we implement a Class C amplifier using a transistor? Right, we can do that by saying the base terminal at a voltage that is very small compared to the ground, minus VBB. So what this minus VBB is doing is taking the base voltage to a value much smaller than 0 volts. So if the emitter is 0, the base is at a negative voltage. What does this mean, and why do we have this minus VBB? Because we want this base emitter junction to be on after the input crosses a limit, that is the magnitude of VBB plus the base emitter voltage. So in order to turn this base emitter junction on, this V in has to cross this VBB, the magnitude of VBB, the positive one, plus the base emitter junction, this voltage drop. So only then this base emitter junction can be turned on. So for that, this input voltage will have to rise very far away, very large, to a very large value, this value. At this value of the input voltage, the transistor will start conduction. It will start conducting. It will start conducting once the input voltage crosses this threshold. And what is this threshold? This threshold is this one, VBB plus VBE. So if it increases, the input voltage increases, this threshold is equal to the magnitude of VBB plus VBE. Only then the transistor will start conducting. And once it starts, we have plotted I out. I out means this IC, the current IC, the current that flows through this RC, the collector resistor. This current is very the magnitude of this current is non-zero only when the input voltage crosses the magnitude of VBB plus VBE, and when the input voltage drops below this threshold, the transistor stops conducting, and we again have zero output. I out is 0. So, and of course, if I out is 0, we get the full VCC at the output. Right, only then we can have this I out, only when the input voltage is in this range, So it is greater than this threshold, and it reaches up to its max value, V peak. Only in this range we have this output current flowing through IC. Right, what can be the maximum AC voltage that we can obtain? Of course, it is biased at a point VCC. And we can have this full VCE set from VCC up to almost a voltage equal to ground, 0 volts. So this is the full swing available for the transistor and this is the swing for current. So VCE sat is approximately equal to 0, a voltage that is very close to 0. So for the output voltage, we have the full VCC. So this can be the swing in the output voltage VCE, and this is the max current, that is of course equal to VCC over R. So the power dissipation, so this can be thought of as the graphs for IC and VCE. For IC is non-zero only when it crosses this threshold I mentioned earlier, and VCE is VCC, and when the transistor start conducting, the VCE voltage drops, and the min value that it can achieve is equal to the saturation voltage VCE sat, that is very closely equal to 0, that is very close to 0. So power dissipation in the transistor is small because it is on for very small time. So what can be the power dissipation when the transistor is on? Of course, the current and the VCE. So if we multiply these two quantities, this is the maximum power dissipation in the transistor when it is on. VCE, the max possible input voltage, this one, the max possible input voltage, that the max possible output voltage, the AC voltage that we can have at the output, and the current flowing through the collector resistor or the output resistor. So we multiply these two quantities, it turns out to be PD on. Average power can be simply computed as, it's an approximate or simple formula to compute average power, T on over T on over the total time, right? The on time divided by the total time times PD on. So let's solve an example, a very small example, where we are given a class C, a basic class C amplifier, for which the input voltage is an AC voltage. For this input voltage, we have the frequency of the input voltage is 200 kilohertz, while the transistor is on for only 1 microseconds. So what's the time period? What's the full time? That, of course, that would be the time period computed from this frequency, 1 over t, 5 microseconds, 1 over f, 5 microseconds. So out of 5 microsecond time period only, it's on only for 1 microsecond, 1 over 5, 2s are 10, only for 20% of the time it's on. IC sat is given to be 100 milliamperes, VC sat is 0.2 volts. So it's a voltage very close to 0. Which voltage? This voltage. This voltage, VC sat, okay, voltage very close to 0. Right, so PD on and PD average are the two unknowns that we have to compute. PD on is VC sat versus IC sat, we studied earlier on the last slide, VC versus IC. So we can compute PD on given this VC and IC sat. It comes out to be 20 milliwatt, and the PD average would be T on over the total time period. We computed that from the given frequency, the input frequency, 1 over F, it's 1 over 200 kilo. So it comes out to be 5 microseconds. So PD average is 4 milliwatts. So average power dissipated in this class C amplifier is 4 milliwatt. Right. We will again use this example in our next lecture, which will be about the tuned operation of class C amplifier. So ECD29 is about a tuned version of class C amplifier. That's all for this. Thank you.